In this lecture, we are going to talk about MSE, RMSE, MAE and R square. So these all concepts will be taught in this lecture. So firstly, what is this MSE, RMSE, MAE and R square? So these are all the evaluation technique. So in this particular course, we have been dealing with only two types of problem. First, regression problem, and second, classification problem. So classification problem is something like whenever we want to classify our input to some labels, like we have a mail, we have a different mail, and that mail can be either spam or that mail can be either not spam. So in that case, we can have either 1 or 0. So we can assign any of the mail either 1 value or 0 value. So that is a classification problem. Now regression takes a continuous data, like we can predict the house price based on the locations. So we have a location, we have the price to be predicted of the house. So this way, the continuous data, whenever there is a continuous data, we use the regression model. And in order to evaluate the regression model, we use this technique. Similar, in order to evaluation the classification model, we are going to learn about confusion matrix in the upcoming lecture. We will use confusion matrix. But now let's talk about this regression model. In this regression model, in order to evaluate the model, so evaluation means to test the model, to test the accuracy of a model, to test whether the regression model worked better or not. So regression is basically only a model. It is just an algorithm, and it is going to give us some output. Now that output should be tested and should be just check whether this model was perfect or not. So in order to check whether model did its best to represent the data or not, we use this technique, which is MSE, which is basically mean squared error. RMSE is root mean squared error. MAE is mean absolute error, and R square is R squared value. So let's learn one by one. Firstly, let's take an example, and I'll start with first MSE. Let's start with MSE. So I'll just take a simple example here. I have this model. So here, this is our linear regression model. So this is a regression task, and our regression task gave this model. So now in this model, we have a data. Let's say our data was, first data is this, second data is this, and I'm going to take third data over here. So this is our 3 data, and our model is this linear regression model. So basically this model is nothing but this graph. So every time you represent any machine learning algorithm, so just remember from now on, every time I use this word model, just remember the graph. In the case of linear regression, the graph will be something like this. As our algorithm increases, the graph also changes. So for the first cases, our graph here is a linear regression, which is a basic straight line. So now our main, that is evaluation technique, is to check whether this line is perfect or not to represent this data. So that is to compute this MSE or RMSE or MAE. So firstly, we will compute this MSE. So how this MSE is computed? Let's see. So this MSE is computed by this formula, which is the summation, and first of all, we take, that is observed value minus predicted value whole square, and this should be from I equal to 1 to n number of data sets. So for each of these data sets, we calculate the observed and predicted. Let's see what this really means. So in this case, if I just compute this formula for our model, the value goes from I equal to 1 to 3, because we have 3 data sets. So for the 3 data sets, n equal to 3. So here we have a 3 data sets. So now what happens is our formula becomes OI minus PI. So now if I compute this, what this really means is I have to compute for each of these data points its observed value and predicted value. So for this first data points, I'll just consider this to be first, this to be second data point, and this to be third data point. Let's see this data point. For this first data point, this observed value, the observed value is this red dot. This red dot is observed value. This observed value is at the predicted value. So prediction is given by this line. So this line, just remember this line is a prediction. So this observed value is colliding, is basically at the top of this predicted value. That means in this case our observed value and predicted value are equal. In this case O1 is equal, because the observed value is actual value. Actual value and the value that is given by this model. Model means this is straight line. So the point, we are going to check only the distance. So distance between this observed and this model line is 0. So that means for the first data points there is no error. So that means it is 0. Let's calculate for the second one. For the second point, the observed is this point. But now we have this model here. So model, let's draw this line. Let's draw the distance to the model. So you can see this distance is our error for data points 2. So we don't have now 0, the sum of square error. So for the second data points, observed is way off than this predicted. So this distance over here is a error. So we just take this error square. This error is also called as a residuals. This error is the distance between predicted is this line is a prediction. So this line to the observed is the distance. So that is the error. And for the third one, we have a certain error. We can see a little error. So error, this is for 1, and let's say this distance is the error 2. And we don't have any error for the first one because actual is at the top of the predicted. So prediction is equal to observed for the first one. There is huge error for the second point. There is a small error for the third. So I'll just say error 1 whole square is for this one, and this is error 2. So error 2 whole square is for this one. So if I compute this value is MSE. This value is going to be mean squared error, where this is mean is nothing but this predicted value. Squared means you take the power, and this is computed as error. Now if this value, the error value, the value that is given by this MSE is 0, if this value is 0, the total value, if the total MSE value is 0, that means our model is perfectly accurate. For that, it should happen something like this. This second point should be also over here. This third point should be also over here. So in that case, our model will be perfectly accurate, because the observed value is accurately predicted by our model. This observed value is also predicted by model, and this is also predicted accurately by the model. So in that case, the error would be 0. So that is what this MSE does. So MSE does basically calculate the error. Error is nothing but the distance between the observed and the predicted by the model, which is observed is O and predicted is P. So observed and predicted distance is the error, and we just square it in order to calculate this mean squared error. Now next thing is RMSE. So RMSE is nothing but, in this formula we have computed this formula. You can clearly see this formula for MSE. Now if I take a square root at the top of this MSE, it becomes RMSE. So this is RMSE. So this is RMSE formula. So now why do we need this RMSE? So that is the important part. So for that we have to learn first of all MAE. So MAE is mean absolute error. So what is the formula of MAE? MAE formula is, let me take a just example over here, and I'll just come back to the RMSE. First of all, let's see the MAE. So we take the example of MSE first. So MSE is the square of error. Similarly, next is MAE. So MAE is mean absolute. Here we have absolute. In the case of mean squared error, we had squared. So we just take a square. Now in the case of mean absolute error, we have absolute. So that means we take a absolute over here. Observed minus predicted. We don't take a square, but this absolute. This absolute is nothing but this modulus. This modulus is our absolute. And I take from I equal 1 to 3 in this case of data set. So let's see here. MSE is basically just taking this value but just squaring those values. but MAE is not squaring this value. So we can clearly say that MAE will be way less. MAE will be very much small than that is MSE, because you can clearly see we only take the error in the case of MAE, but we get the error square in the case of MSE. So you can say the 2 will be MAE and 2 square will be MSE. So 2 square will be MSE. So why do we use this MSE? In order to punish the larger error. So if we have larger error, so if I say if I have this larger error, if we just square this larger error, then this error will be huge, and we will just punish our model saying that this model has huge error, try to reduce this distance, try to reduce this residual distance or the error. So this is a punishment that we will be giving to our model considering this MSE and RMSE. Now second is RMSE. So after taking this root of MSE, some value will come, that is basically RMSE, and this will be standard that is related to MAE. So we can compare now RMSE and MAE because it is a root, and if you just take a square here, if you take just a root of this, then you can just completely just ignore this square at the top of it, although we have a summation obviously, but just theoretically we can just remove this square. So that means it will come as a standard to MAE. So now MSE and RMSE can be compared. So in the case of MSE and RMSE, only in one cases RMSE and MAE will be equal. MAE and RMSE will be equal only in one instance, whenever there is evenly distributed error. Other than that, always RMSE will be greater than MAE. So that is the reason we use the RMSE to check whether our model has correctly predicted or not. So this is all about RMSE, MAE and MSE. So in the upcoming lecture we are going to talk about R square, and we are going to close the chapter of regression. So see you in the next one.